Hi everyone, I'm Brandon Armstrong and I'm an aquatic biologist in Eagle's Water Resources Division. Today I'm going to be giving you an overview of our PFAS monitoring in fish and surface water in Lake Superior. The state has taken a multifaceted approach to tracking down PFAS contamination in Michigan's watersheds. So in addition to surveying both surface water and fish tissue for PFAS concentrations, we rely on public reporting of surface foams that may be characteristic of PFAS containing foam, such as you see pictured here with this bright white fluffy foam that's forming on the shoreline of an inland lake. We also have an industrial pretreatment program that's characterizing PFAS and wastewater effluent from wastewater treatment plants that receive industrial waste. We also look at other matrices like stormwater and biosolids for PFAS. So I'll start with the surface water concentrations for Lake Superior and its tributaries. So in 2021, we did a pretty large-scale study in the Keweenaw Peninsula of the Upper Peninsula where we hit many watersheds within that region when collecting surface water samples for PFAS analysis. So the map you see here, each circle is a surface water sample, and as you get darker in color, you have a higher PFOS concentrations here reported in parts per trillion. So the dark burgundy colored circles there indicate a sample that has a concentration greater than 12 part per trillion. And that 12 part per trillion is significant because that is the water quality value for PFOS. So any areas where we have surface water exceedances for PFOS or PFOA, we'd like to follow up to do additional monitoring to try to track down those sources of contamination. So that work is ongoing in this area. In 2022, we are planning on collecting samples throughout both the Two-Hearted River and Contaminant River watersheds. And this sampling was initiated based off of elevated concentrations of PFOS in fish tissue from a lake that's situated right on the border of these two water bodies. And we'll talk about those concentrations in a few more slides. If you're interested in any of our surface water data, I encourage you to visit the Michigan PFAS Action and Response Team, or otherwise known as MPART. Their website, if you just Google Michigan MPART, that'll pop up and you can click on the home page. And on the home page, you'll see a link for the PFAS information system, which will take you to the screenshot shown here. And that's where all of our surface water data is housed. In addition to the surface water data, it also has a layer for public drinking water supply PFAS data, as well as the locations of all of our MPART PFAS sites. And PFAS sites in this context are locations where we have groundwater PFAS concentrations exceeding the groundwater cleanup criteria. So one of my roles with Eagle is to coordinate the fish contaminant monitoring program. This program has two overall goals to assess contaminants in fish. The first and most important is to assess contaminants in the edible portion of fish. So that would be largely fillet concentrations. With some species like smelt, we look at headless and gutted concentrations. So that would be looking at data that may be of importance to fish consumers. So that data that's generated from this portion of the fish contaminant monitoring program is sent over to the Michigan Department of Health and Human Services and evaluated to determine whether or not fish consumption advisories are warranted. The second goal of this program is to assess both spatial and temporal trends. We have a couple different tools at our disposal to assess those trends. The first is to look at whole fish across the state. So we've been doing this for several decades now, looking at concentrations in whole fish at select fixed locations about on a 5-year basis to look at change of those contaminants over time. And then more watershed focus, we can either deploy caged fish or use passive samplers to assess spatial concentrations of contaminants across an entire watershed. Putting cages or passive samplers upstream and downstream of known or suspected sources of the contamination. So in 2021, the state of Wisconsin issued a fish consumption advisory for rainbow smelt from Lake Superior due to elevated concentrations of PFOS that they had observed in samples that were collected the previous year. So after discussions with Wisconsin, we developed this monitoring plan to look at smelt concentrations, smelt contaminant concentrations across Lake Superior from multiple locations. And as you can see pictured here, we ended up hitting up 7 general sampling locations for those Lake Superior smelt. And this effort was in coordination with both the Michigan Department of Health and Human Services, the Michigan Department of Natural Resources, the Keweenaw Bay Indian Community, Bay Mills Indian Community, and the U.S. Geological Survey. So there was a lot of effort going out last year to get these samples collected. And overall, the take-home message here is that PFOS concentrations in rainbow smelt from Lake Superior can be highly variable. Starting here in Contaminant Bay, the PFOS concentrations in those samples was 2.8 part per billion. That was the lowest that we had observed in smelt from these sampling locations. The highest concentration of PFAS that we saw in the smelt was over here off 14 Mile Point near Ontonagon. And the concentration in that sample was 112 parts per billion. So again, highly variable from anywhere from 3 part per billion up to 112 part per billion. And then the other point here is on the east side. This is trawls that USGS had conducted in Whitefish Bay. We composited 2 samples. The first sample was looking at composites of those headless and gutted, so that's the edible portion concentrations of PFAS that people would be consuming. And the average concentration in that sample was 63 parts per billion. The other sample was left as whole fish, and the concentration in that sample was 185 parts per billion, so about 3 times higher in whole fish than we saw in the edible portion. So another sampling effort that we did last year for rainbow smelt was to look at 2 inland populations here in the lower peninsula. We selected Higgins Lake and Gull Lake because those are 2 highly fished water bodies for smelt. And the average concentration in Higgins Lake smelt was 34 parts per billion, whereas Gull Lake was 72 parts per billion. And so the take home here is that the concentrations of PFOS that we're seeing in those Lake Superior smelt really shouldn't speak to a significant PFAS source to Lake Superior, more so than it would speak to how bioaccumulative this particular compound can be in rainbow smelt. So for some reason this species is accumulating in much higher concentrations of PFAS than other species that have been tested. So for example, in Gull Lake, we have, while the Gull Lake is adjacent to a M-part PFAS site where we have contaminated groundwater, the surface water concentrations in warm water species like largemouth bass have shown relatively low concentrations of PFAS in those samples. So it was rather surprising to see the concentration of 72 parts per billion come back for those rainbow smelt. We haven't really quite figured out why smelt accumulate higher concentrations of PFAS, so that's something that's yet to be determined. But I just wanted to kind of highlight that while we are seeing high concentrations in Lake Superior, we really can't say that there's a significant source of PFAS to such a large water body. We have assessed other species of fish from Lake Superior and its tributaries for PFAS. We've looked at lake whitefish and lake trout in Lake Superior. We've looked at walleye from a couple of tributaries, as well as rock bass, yellow perch, carp, and smallmouth bass from tributaries over here on the east side of Lake Superior. This table summarizes both the range and average concentrations of PFOS in parts per billion from those species and locations that were shown on the previous map. Now the take-home message here, without getting too caught up in the weeds of the data, is that generally speaking, fish from both Lake Superior and its tributaries that have been tested for PFAS have relatively low concentrations of PFAS, the exception being those rainbow smelt that we previously discussed and those 2 water bodies at the bottom of the map. So Silver Ledge Creek is near Gwinn. It's adjacent to an M-part PFAS site where elevated surface water PFAS concentrations have been found. And in 2017, we found elevated concentrations in brook trout from that creek. And then the second water body is Pike Lake over in Luce County. We just recently got PFAS data back for this system and found elevated concentrations of PFAS from several species of fish in that lake. And that's what triggered the 2022 surface water sampling in both the Contaminant and Two Hearted watersheds that we're going to conduct this year. So we're going to try to figure out, what the source of contamination to Pike Lake is and whether or not nearby water bodies have been impacted. So just to wrap up, the two really main take-home points here. First is that, the majority of the surface waters that we've analyzed for PFAS have met our water quality standards for PFOS and PFOA. So thinking back to that first map that I shared, there were just a few, maybe a handful or so of water bodies where we had PFAS exceedances. So we're going to continue to follow up on that data to try to track down those sources of contamination. And then the second take home here is that the majority of those fish that we've analyzed from Lake Superior and its tributaries have had relatively low PFOS concentrations, the exception being those rainbow smelt that seem to accumulate much higher concentrations of PFOS than these other species, as well as those two inland water bodies, again, Silver Lead Creek near Gwinn, Pike Lake up in Lewis County. Silver Lead Creek, the contamination source is known, and the Pike Lake's contamination source is currently unknown, so we're going to be doing some follow-up monitoring in those watersheds to try to track down that source of contamination. And with that, I believe I'm ready for questions. Thank you.